All right, so for our next video, we're going to look at solids of revolution and cross sections. We're actually going to start with cross sections. All right, so cross sections are if you take a 3D shape and you kind of slice it in some manner. All right, the 2D shape that's formed when you slice it is going to be your cross section. Right, so like here I have this cake, right? It's got like if you imagine the whole cake, right? It's going to be kind of like this, right? Where you've got like a little cylinder on top of a big cylinder, right? Rough sketch. But your cross section ends up being this part here that's got like icing on it, right? This like rectangle over a rectangle kind of shape, right? That is the cross section. Right, so if you imagine taking a 3D shape and cutting it in some way, it doesn't have to be straight down. It could be at an angle or something. But the 2D shape that is formed is your cross section. Okay, we do have some patterns. It's stuff that's going to happen every time with these shapes. Now, the one shape that we're missing here is our sphere. But with a sphere, no matter which way you slice it, it's always going to give you a circle. So that one's kind of easy. We're not really going to focus on it. All right, but if I take any of our other four shapes, and I slice it parallel to the base. All right, so like for our first two, we got our cone and a pyramid, right? A cone's kind of like a circular pyramid that kind of go together. So for a cone, if I slice it parallel to the base, it's going to give me a circle. Not the same exact circle. It's going to be a little bit smaller the higher you go, but it's going to give you that circle. It's going to basically make a smaller cone if you were to slice it. All right, for our pyramid, in this case, it looks like we have some sort of rectangular pyramid, right? So if I slice it or if I run this plane through it, that's what this red rectangle is, the green rectangle ends up being my cross section, all right? And again, it's like I'm making a smaller pyramid, like chopping off the base. All right, for our cylinder, same idea as a cone, right? If I slice it, I'm going to get a circular cross section, but now this is the exact same circle that's on the bottom. Right? It's like I'm slicing off the bottom of my cylinder and just making it a shorter cylinder. Okay, my prism, right? Side note, just to remember, when it comes to your prisms, right? Even though this one's sitting on this rectangle on the bottom, that's a rough rectangle, that does not mean that it's a base. All right, that's like if I turn my cylinder on its side, okay, my bases are still a circle. Right? So for your prisms, you got to remember the non-rectangular shapes, right? So this triangle, which I cannot draw. Okay, the non-rectangular shape has to be your base, right? So in this case, my base is a triangle. And you notice that if I were to slice it right down the middle there, I would also have a triangle for a cross section. So anytime I go parallel to the base for these four shapes, and it doesn't matter what your base is for the pyramid or the prism, right? It could be an octagon, it could be a square, it doesn't matter. All right, your cross section is going to be the same shape as the base. Not necessarily the same size, right? For our cone and pyramid, it gets smaller the higher up you go. But for our cylinder and prism, it is the same shape and size. It's congruent to the base, right? But parallel to the base is the same shape for your cross section. The other pattern is if it's perpendicular to the base. And I drew a little squiggle here because your cone and pyramid is a little different than the cylinder and prism. Right? So for the cone and pyramid, one important part, the only way that this works for the pattern, is if your cross section goes through the top vertex. Okay, it's got to go through the top vertex, right? The point. All right, if it doesn't go through the point, it isn't going to necessarily be the same shape. It might be something different, right? But for our cone and the pyramid, if you go through that top point and you're perpendicular to the base, right, it's always going to be a triangle for both. Okay, every time. For our cylinder and our prism, if I go perpendicular to the base, for both of them, it's always going to be a rectangle. You don't have to worry about anything specific, but it's always going to be a rectangle if I'm perpendicular to the base for these two shapes, right? Remember, it's triangle for pyramid and cone, rectangle for prism and cylinder, but for your pyramid and cone, it's got to go through that top point. All right, and I'll show you an example in a second of what it would look like if it didn't. Okay, so those are our two set patterns. Other than that, you're just going to have to kind of visualize. All right, I have a cross sections website. If you go to my class page, right, there's a link under the Honors Math 3 and Honors Resources page. It just says cross sections website. All right, it's a pretty cool website, and I'm going to share that with you now. That you can go if you want to play around with it. It's just to help you visualize what these cross sections are going to look like. Okay, so like for example, here is a prism that looks like it's got, let's see, what, 10 sides? So it looks like a decagon for the base. Okay, and it looks like here I'm parallel to the base, so it's the same decagon that's on the bottom. All right, but you can decide, you can get rid of some of them. If I want to go back, like there's a hexagon or a pentagon. So you can kind of choose, what you want your shape to look like. And then you can rotate around however you want it, move the slice up and down, stuff like that. Okay, so it's a pretty cool way of visualizing what your cross section is going to look like, right? And you can click and drag and turn this all the way around. Right now, if I go back to that cone and pyramid deal, right? Here I am, parallel to the base. It's going to be the same shape as the base, just a different size. But if I rotate this all around, okay, and try to get it perpendicular, right? Notice that this is not your triangle, right? Because it doesn't go through that top point, right? It gets cut off, so then you have this little piece, right? And it makes this quadrilateral. It's not really a trapezoid or anything. It could be more of a trapezoid shape. If you kind of rotate it a little bit, I can't get it exact, but see how you could have a trapezoid, right? If you go down, it looks more like a trapezoid. All right, but it's not necessarily always going to be a triangle. It's got to go through that top point to get the top point of your triangle. And same thing with a cone. But with a cone, it's going to have like a curve, almost like a parabola, right? Well, I mean, it is a parabola for that part, right? And then again, if you move it, oops, wrong way, move slice up, right? You can keep going until you get closer to that point. It gets to be more and more and more like a triangle. Went too far. All right, and there we go. Okay, there's your triangle as long as it goes to that point. All right, and then you can animate so it shows you. Pretty cool website if you want to check it out, right? And look, you can even get to an oval in there for your cone, right? So you just gotta be able to visualize. Let me get back to our presentation. All right. Now we're going to use these cross sections for the next part, which has to do with rotating solids, or solids of revolution. So that means we're taking a cross section and we're rotating it to get a 3D shape. So it's kind of the opposite of what we just looked at with our cross sections. We're going to focus on two main shapes, a rectangle and a triangle, but you do have to be able to apply this idea with some non-traditional shapes, right? So to start with, we're going to talk about rotating a rectangle. So it's like I'm taking this rectangle and I'm rotating it around this axis, right? You see the arrow down here means I'm kind of rotating it this way, right? The first thing you can do to help visualize is reflect. Let me change colors. Well, no, we'll leave it. Is to reflect it over your axis. Okay, so here's like I just went 180, went halfway around that full rotation. All right, so then if you imagine what that shape looks like, right, if you kind of put the rounded edges in there, we end up with a cylinder. All right, so if I rotate a rectangle around one of its sides, it's going to give me the 3D shape cylinder. All right, now the second one, still a rectangle, or it looks like a square, but if I take and rotate this one around that axis, it's going to be a little different because I have a gap in there. So I can start off the same way. All right, I can try to reflect this over. Okay, but then when I go to draw my curves, all right, if you imagine this rotating around, all right, now I'm going to end up with two cylinders. Okay, I have like an outer cylinder and an inner cylinder, so you can, let me draw those lines. You can kind of see that it's like a hole in the middle, right? So this is a cylinder with a cylindrical hole, but I call it toilet paper roll. right? Which is kind of ironic with all of the toilet paper issues we're dealing with right now, right? But this is a toilet paper roll, so it's a solid cylinder with a hole in the middle. So a big cylinder with a little cylinder hole. Okay, so those are our two options if I rotate a rectangle, and we'll do some examples of that in just a minute. Okay, or I could rotate a triangle, right? So this triangle I'm going to take and rotate around this side here, right? So the first thing we're going to do is reflect it over, try to, right? And then we'll kind of draw our curves in there. Okay, everything we rotate is going to be circular in some way because we're rotating it, right? And that's a circular motion. So in this case, that red shape ends up being a cylinder, or sorry, not a cylinder, a cone. So if I rotate a triangle on one of its sides, right, one of its legs, because this is actually specifically a right triangle. So if I rotate the right triangle on one of its legs, it's going to give me a cone. All right, and the last option is if, let me draw it on there because I didn't have a picture of it, is if I were to rotate a triangle around an axis or a line that is at one of its vertices. All right, so now instead of using a side, I'm going to be using one of its angles. So we'll start by reflecting and then drawing in our, like the curved circular parts. All right, so now with this shape, I clearly have a big cylinder, right? It looks like the first one we had over here, but then I also have this like upside down cone going in there. Right, so this one is a cylinder with a cone hole, right? And I call this one a bowl, kind of, right? Or a cup or something, because it's like, you know, you could take some water and pour it in here, right? Because this is hollow, right? It's got you know, to hold water. Okay, so now I've got a cylinder with a cone on the inside. So if you rotate a rectangle, it's going to be something to do with a cylinder. If you rotate a triangle, it's going to be something to do with a cone, right? And then the other thing you got to be able to do, we're going to be asked to find volume and stuff like we've been doing for these shapes. But in order to find volume, you've got to know some dimensions, right? So pay attention to what it looks like, right? Like you can, this one's kind of easy. The height, right, is going to be how tall it is. Same thing for all of these. Like this leg of my triangle is going to be the height. Here's my height. And then the leg of my triangle is my height. So those are kind of the easy ones. The radius is where it gets a little tricky, right? Your radius, right, for the cylinder is actually going to be part of your rectangle, one of the sides of your rectangle. And that's an R. Right? For your toilet paper roll, it's a little bit harder because it's not going to be just the side. Like this is not the radius. That's only a part of that big radius. You have to go from the axis that you're rotating it around to the outside of that big cylinder. So that's going to be the radius of the big cylinder. And then the radius of the little cylinder is going to go from the axis, right, to the edge of the little cylinder. So that's the radius of the small one, right? And that's also the gap. Okay, so whatever the gap is between the rectangle and what you're rotating around is the radius of the small cylinder on the inside, right? And then for your cone, the radius is the other leg of your triangle, right? And then for the cone and cylinder here, or for both of them, yeah, your radius is the other leg of your triangle. Okay, so we're going to take all of that and put it into action and do a couple of examples. Right, so our first one's dealing with a rectangle. So example 1, it gives me this rectangle and it says that I'm rotating it around these 3 options to get a 3D shape, and I want to find the volume of each of these. Okay, so I'm going to use different colors here and try to keep it, you know, separated so you can see what's what, but my picture is going to get a little bit messy. All right, so first I'm going to graph it. First things first. I got 0, -2, 0, 2, 3, 2, and 3, -2. So here's my rectangle that I'm working with, all right? I'm going to color it in a little bit so that we can always see it. Okay, now the first one I will do in green. So the first one says that we're rotating it about the y-axis. So here's my y-axis. The first thing I'm going to do is reflect it. I'm going to come on this side, put another rectangle. Then I can draw in my circles. Okay, so I'm rotating a rectangle. I know it has to do something with cylinders. All right, and I'm going to put a dotted line over there because that's not one you would see if it was filled in. All right, so this one doesn't have a gap, which means it's going to be a cylinder because the rectangle touches the y-axis. All right, to find the volume of a cylinder, remember the volume of any prism or cylinder is the area of the base times the height, but specifically a cylinder always has a circular base, so that's always going to be pi r squared h. All right, so for this one, I'm going to have pi times the radius of the cylinder, which is going to be the top part of my rectangle here, so 3 squared times the height, which is going to be the height of my rectangle, which is 4. Uh-oh. All right, 3 squared is 9. 9 times 4 is 36. So we get 36 pi, and we'll just leave it in terms of pi so that we have an exact answer and we don't round it. All right, that was it for that one. For our second one, let's see, I'm going to switch to orange. Okay, for our second one, I'm going about the x-axis. So here's my x-axis. This is a little different. It runs through the middle of my rectangle. All right, so that means if I start rotating it around, it's just going to be rotating onto itself, right? Like if I were to reflect this across the x-axis, it's going to be the exact same rectangle. So I'm just going to go ahead and draw some circles. All right, and then there's my cylinder. All right, just a little different. So now this cylinder is on its side, right? So then if I want to find the volume, let's see, this one's a cylinder. Okay, I need pi times the radius. So now the radius here is actually going to be half of this side of the rectangle, right? So this top part here is only 2, right? And then the height of this cylinder is going to be the top part of my rectangle, which is 3. Well, 2 squared is 4 times 3 is 12. So we get 12 pi. All right, and then one more. I'm going to kind of draw over my rectangle again, just so we can see it a little better. Okay, so there's my rectangle. Now I'm going to take that rectangle and I'm going to rotate it about, let's see, we'll use red. And I'm going to rotate it about x equals -1. So if I have x equals -1, x equals means it's a vertical line. So my vertical line is over here. And you know, I don't like red. It's too close to orange. What's a color? Let's do blue. Let's do this one. All right, so I'm going to have my -1 vertical line here. So now this one's a gap. My rectangle does not touch the line x equals -1. So that tells me this one's going to be a toilet paper roll. All right, so I'm going to start by reflecting my rectangle like that. Then I'm going to have a little cylinder and a big cylinder. All right, and then a little cylinder, which will do dotted lines, so it's on the inside, and then a big cylinder. So there's my toilet paper roll in blue, and it's kind of hard to see with all the other colors on there. All right, but to figure out the volume of this toilet paper roll, because it's hollow in the middle, right, that's not part of my volume, okay? That's not something that's not part of the 3D shape. So I'm going to take the volume of my big cylinder, and I'm going to subtract the volume of the small cylinder, the inside. All right, well, to find the volume of the big, it's going to be pi times the radius squared. And we said the radius has to go from the middle, so from this line that I'm rotating, out to the outside of my rectangle. And so that actually ends up being 4 because there's a gap of 1 and then the 3 for the rectangle. So my radius of the big cylinder is 4. The height is going to be the height of my rectangle, which is also 4. And then I'm going to subtract the volume of the little cylinder. So my radius of the little cylinder is the gap, which is 1 unit. And the height is the same height as the other cylinder, 4. All right, well, 4 squared is 16 times 4 is 64. And then 1 squared is 1 times 4 is 4. Okay, now in this case, I got 64 pi minus 4 pi. So those are like terms, right? They all have pi. So that means I really have 60 pi for my answer. All right. One more example. Same idea, but now we're going to be working with a triangle. Okay, so this one's a little different because instead of giving you the points, I'm giving you equations, right? So it says these three lines, y equals 3/2 x, y equals 0, and x equals 2, form a triangle. Then I want to find the volume of the shape when you rotate around those three options. Okay, so to start with, I am going to graph it. All right, so 3/2 x, right? That is mx plus b, where b is 0. Right, then I'm going to have a slope of 3/2. So I go up 3 over 2, up 3 over 2, right, and then down 3 over 2, down 3 over 2. Now I'm just going all the way, filling up this coordinate grid. That way I, know exactly where it's going to cross. But I'm not going to draw the line yet because I don't want it to get super, super messy. Right, but I do know that the line's going to be going through these points, okay? My second one is y equals 0. Well, y equals 0 is a horizontal line because it's y equals, and it's at 0, which is actually my x-axis. So there's already a line there for that, right? And then my third one is x equals 2. So x equals 2 is a vertical line at 2, right? So it's going to go through here and go all the way up and down. But I can see that I'm going to have a triangle right here. All right. And I already see a typo on here. This one is supposed to be x-axis. Oops. All right, so the first thing is around x equals 2. So let me color in my shape here again just so we can see it. All right, so go with green again. All right, so my first shape is going to be rotating around x equals 2. So x equals 2 is that same dotted line that we already drew on there. Right, which is one of the sides of my triangle. So that tells me it's going to be a cone, right? So we'll look at that cone. So I'm going to reflect my triangle over and then draw in my curve. So I have a cone. To find the volume of a cone, right, like a pyramid, it's 1/3 area of the base times the height, right? But your cone always has a circle base. So just like our cylinder, we can get more specific. And it's always going to be 1/3 pi r squared h. All right, so for this one, we have 1/3 pi in my radius. So my radius is the bottom of my triangle here, which is 2. And then my height, right, is 3, the other leg of my triangle. All right, well, 2 squared is 4. 4 times 3 is 12. And 1/3 of 12 is 4. So my volume is 4 pi. All right, for the next one, okay, I want to go on the x-axis. So that's down here. Then I'm going to reflect it down. So I got to go down 3 and then go to the origin. So again, I have another cone because I'm reflecting it around, oops, one of the sides. All right, so then my volume is going to be 1/3 times pi. Now the radius this time it switches. So my radius this time is the right side of my triangle there, which is 3. And now my height is the other leg, which is 2. All right, well, 3 squared is 9. 9 times 2 is 18. 1/3 of 18 is 6. So my volume is 6 pi. All right, and then for the last one, let's see, I did this color blue. So for the last one, I want to rotate around x equals -1. So let me color over my triangle again so we can see it. So now x equals -1 is a vertical line, right? And, oh, that is not the one I wanted either. Look at this, no typo. I changed the problem on me. All right, so this one should be y-axis. I had a different triangle originally, so my apologies. Forgot to change this part. All right, so my y-axis, all right, goes down here. Okay, so now this one is on a vertex. It's on one of the corners of my triangle. So that tells me that this one's going to be our bowl or cup shape. or the one where I have a cylinder with a cone cut out. Right, so I'm going to start by reflecting it so we can see what this looks like. And then we will draw our circles. All right, so now I have this big cylinder with a cone in the middle. All right, so to find the volume, I'm going to have to take the volume of the cylinder minus the volume of the cone. Right, because that cone is like the hollow part, it's open. All right, so the volume of a cylinder is pi r squared h. So that's going to be pi. Now the radius for both of these goes from the middle to the outside, it's 2. All right, squared times my height, which is the same height as my triangle, which is 3, sorry. Minus, right, 1/3 times pi times my radius, which is still 2, times the height, 3. Okay, now you could technically simplify, some other stuff using our equations, but we're just going to keep plugging in. So 2 times 2 is 4, times 3 is 12, minus, and then we've got 2 squared is 4, times 3 is 12, and then 1/3 of 12 is 4, right? So then 12 pi minus 4 pi is 8 pi. Okay, and again, there's a couple other ways that you can simplify this, but all you need to be able to do is plug in, right? Leave it in terms of pi unless the options are with decimals, but usually they're going to be left in terms of pi so that they are exact. Okay, so there's our cross sections and our solids of revolution.